Multiplying powers with the same base. Property of exponents, we can multiply these powers of the same base, and when we multiply powers with the same base, we're going to add our exponents. And as we've talked in previous, let's see here, we talk about bases, right? So I have a to the n power. N power. So a would be my base, n would be my exponent. And when multiplying like bases, that would be an example of, well, if I had a to the m power. So a to the n times a to the m would be the same thing as a to the n plus m, because I'm going to add those exponents together. Now, m and n happen to be in this rule, happen to be a variable, so I can't combine them any further. But the examples that we're going to begin with will be numbers, and numbers we can combine. So as we look at what is multiplying powers, what is each expression written using each base only once? So as we take a look here in A, we have 8 to the third times 8 to the sixth. My bases are the same, so we are going to add our exponents. So that would be the same as 8 to the third plus 6th power, which is going to be 8 to the ninth. 3 plus 6 is 9. Again, it's not asking me to simplify that. I could multiply that out or put it in the calculator and get the number, but it's asking me to simply write this using just one base. So as I go to the next example, I have 0.5 to the negative third times 0.5 to the negative 8. Now remember, we're going to add bases. We add exponents when multiplying like bases. So I would have 0.5 to the negative third plus negative 8. So when I go to combine those, that turns out to be 0.5 to the negative 11. And if I'm going to simplify that, I may want to make sure that I do it so with a positive exponent, which would be the same as 1 over 0.5 to the positive 11 power. Again, both equal statements. One has a negative exponent, one has a positive exponent. All right, so looking at my 9, well, the only thing here, looking at C, right? I happen to have 3 bases that I'm multiplying together, or the same base multiplied together 3 times, but have 3 different exponents. Again, we add the exponents, or combine like terms, combine exponents. So I am going to have 9. Then my exponents, negative 3 plus a positive 2 plus a positive 6 is going to give me 9 to the 5th power. That is 8 minus 3 to the 5th power. Continuing on with my examples, I have 9 to the 5th times 9 to the 3rd, which is going to be 9 to the 5 plus 3, and that is going to be 9 to the 8th power. Let's see here, I don't want to use yellow, so I'll take negative 3 to the negative 2 plus 10 power is going to be negative 3 to the 8th power. And then my final example here is going to be negative 8. Okay, it gives me negative 8 to the 5 plus a negative 5, which is going to be negative 8 to the 0 power, which is also equal to 1, if you recall from the previous lesson. So there you go, adding the same bases like bases. So now we're going to talk about, those were numbers, but now let's go ahead and talk about when we use algebraic expressions. Simplified form of each expression. Well, the same rules apply. We know here that what is the simplified form of each expression? So we have what looks to be 3 expressions being multiplied together. And let's just look at it. We have 5x to the 4th times x to the 4th times 3x. And that, of course, is x to the 1st. We also know that that 5 is to the 1st and that 3 is to the 1st. But let's go ahead and like bases, right? Well, well, let's do what we can do. We know that we have 5 times 3. We have 5 times 3 that we can multiply together. And now let's take our like bases. Right here are my x's. And I am going to have x to the 4th times x to the 4th times x to the 1st. So when I rewrite that, it's going to give me 15 times x to the 4 plus 4 plus 1, which is going to give me 15x to the 9th. And there you have it. We have done some algebraic expression simplification. Okay, looking at this next expression, let's go ahead and let's see here. Let's combine what we can combine. We have, looks like we have -4 times 7 times 2, right? We have those times my c to the 3rd times c to the -2nd, those guys right there, times d to the 2nd. And I think I have included everything in my rewrite. So let's go ahead and do what we can do. That is a times multiplication sign. We'll make sure it didn't look like a subtraction. So it turns out I have -56 times c to the 3rd plus c to the -2 times d to the 2nd. And then I have -56 times c to the 1st times d to the 2nd. So there you go. We have simplified that expression as much as possible. Let's see, keep on moving. Okay, it looks like we do have some like variables, some like bases that we can combine. And I know that I have 12. I have nothing to multiply 12 to except for 1, so I don't need to do anything special there. And then I have j to the 2nd, I'm sorry, I got to be careful with my j's. J to the 2nd and j to the 1st, and I also have k to the -2nd. That simplifies down to 12 times j2 plus 1, and then k -2. So we have 12j to the 3rd. And I'm going to do this reciprocal thing right here to make that a positive exponent. So that should be over k to the +2nd. There we go. So I just did those two operations there to simplify my expression. So we again, as a special note over here, we know that negative exponent is the reciprocal. So k to the -2 is equal to 1 over k to the 2, +2. So that's what I did right there in that step. Okay, so if we talk about scientific notation, at 20 degrees Celsius, 1 cubic meter of water has a mass of about 9.98 times 10 to the 5th grams. Each gram of water contains about 3.34 times 10 to the 22nd molecules of water. About how many molecules of water does the droplet of water contain? Okay, so they've given me a droplet of water right here, and they basically told me my volume. I'm guessing molecules is going to be 1.13 times 10 to the -7th, which is very small. So remembering scientific notation, if I have 9.98 times 10 to the 5th, that is the +5 means I'm going to move that decimal 5 places. So I'm going to have 9, 9, 8. So that would be 1, 2, 3, 4, 5 places. So that is actually meant to represent 998,000. And then, of course, when we have -7, if I have 1.13 times 10 to the -7, well, negative, I'm going to be moving it to the left because I'm making a smaller number because it is a negative exponent. So just keep that in mind when we're talking about scientific notation. So with that, we are going to do some multiplication here. So what do we have here? We have how many molecules of water does a droplet contain? And we have, let's see here, 1 cubic meter of water has a mass of this many grams. And then each gram of that water contains this many molecules. And then it says how many molecules of water does this much water contain. So we're going to multiply all those together. So in doing so, we are going to have our volume is going to be multiplied by our mass. And we're going to multiply that by how many molecules of water are in each gram. And now when we multiply this all out, we do have some stuff that we can multiply together. So we have our numbers, which we can go ahead and multiply together. And then we're going to have our tens to the exponent, which is part of our scientific notation, but those are going to be like bases, so we're going to be able to multiply those together and add our bases. Okay, so as we do some multiplication here, I've gone and I've taken my numbers and I'm going to multiply them all together times now my like bases. I'm going to multiply them together. So I end up with 37.7 times 10 to the negative 7 plus 5 plus 22. And that is going to give me 37.7 times 10 to the 20th. Well, it's not in scientific notation now because we have, a 37 versus 3.7. So when I go to change it into scientific notation, I'm going to have 3.77 times 10 to the 21st now instead of 10 to the 20th. So there we go. That's my answer, doing some multiplication. And we're going to continue on with this next one. And it's asking me, well, about how many molecules of water are in a swimming pool that holds 200 cubic meters of water, and then write it in scientific notation. Well, what we're going to be replacing here is our volume of water. That's what's going to replace here. Otherwise, our ratios or our calculations for our molecules and our mass are going to remain the same. But we're going to change the amount of volume that we were using, and that is going to be 200 cubic meters, which in scientific notation will be 2 times 10 to the second. So if I have 2 times 10 to the second. Now as we go ahead and do the math here, we're going to have 2 times 9.98 times 3.34 times 10 to the second times 10 to the fifth times 10 to the 22nd. And my wife just will not stop blowing up my phone this morning. Okay, so when we multiply all this out, we end up with 66.67 times 10 like bases. So we add our exponents, 2 plus 5 plus 22. And we end up with 66.67 times 10 to the 29th. And of course, continuing to convert to scientific notation, I'm going to end up with 6.67 times 10 to the 30th. There you go. Large number. As we have 30 positive 30 positive places we would move that decimal. The value of using scientific notation. So there you have it. And in context, those are our molecules of water. So simplifying expressions with rational exponents. We're going to do this without a calculator, and we're going to learn some conversions later on. But for right now, we are just looking to do this with the mathematical knowledge that we know and the use of exponents. So as we look at this, we have simplified this expression in 16 to the 1/4 power. Well, what that is asking us is what number multiplied by itself 4 times is equal to 16. And we should hopefully be able to say, well, we know that 2 times 2 times 2 times 2 is equal to 16. Therefore, 16 to the 1/4 power is going to be 2. As we continue with that same, we look at B here, and it's asking us what number multiplied times itself 3 times is going to be equal to 27. And we know that 3 times 3 times 3 is 27, so therefore the answer is 3. Again, continuing on. What number multiplied times itself twice is going to be equal to 64? Well, we know that 8 times 8 is equal to 64. Therefore, the answer is 8. So as we continue on, we start to get a little bit more complicated here, and it looks like we have 25 to the 3/2 power. Well, I can rewrite that a little bit easier, and I could say, well, that is technically 25 to the 1/2 times 25 to the 1/2 times 25 to the 1/2, because we just learned that when we are multiplying like bases, we add the exponents. So 1/2 plus 1/2 plus 1/2 is going to give me that 3/2. So I've just expanded this expression out, and so I'm asking myself here, what number multiplied by itself twice is going to give me 25? Well, that is 5. So here we are looking at 5. 5 times 5 is 25. So this answer is 5. This answer is 5. This answer is 5. And therefore, when we simplify this entire expression, it becomes 5 times 5 times 5, which is 125. Continuing on with our examples, I'm going to break this 27 up into this fraction, right? I'm going to break it up into 27 1/3 times 27 1/3 like bases. What number multiplied times itself 3 times will give me 27? Well, that is 3 times 3 times 3 is 27, so I know that this is going to be 3, and I know then that this is going to be 3. Therefore, 3 times 3 is going to give me 9. Continuing on, hopefully we start to see a pattern here. I'm going to break this up with into elements of 16 1/4 times 16 1/4 times 16 1/4. So I'm asking myself, and we've already done this problem, what number multiplied times itself 4 times is going to give me 16 right here. So we determined that 2 times 2 times 2 times 2 is 16. So that answer is going to be 2 times 2 times 2, which is 8. And yes, number-wise, you could have put this into the calculator and it would have come up with 8. However, these are some basic math properties that we are trying to understand. That's why we're doing it without a calculator. Grasp the fraction and work with it, otherwise forever be in fear. Okay, so simplifying G here. Now we start to get into variables, which will not go directly into the calculator. So I'm going to bring out some stuff. I know that this is going to be 2 times 2. And then we have c to the 3/5 times c to the 1/5. So I'm going to have 4 times c to the 1/5 times c to the 1/5. Actually, I don't need to do that, do I? There's no numbers to find. C to the 3/5 times c to the 1/5, and we know that when we are multiplying like bases, we go ahead and add our exponents. So I have 4 times c to the 3/5 plus 1/5, which is going to be equal to 4c to the 4/5. There we go, that expression simplified. And continuing on with the next example, h, here we have n to the 1/3 power plus n to the 4/3 power. So we write that as n to the 1/3 plus 4/3 because it is a like base. And that gives us n is equal to 5/3. There you go. Started to mess up that, but I tried to fix it. Moving forward, got a bunch of stuff here, right there. B to the 2/3 times C to the 2/5 times B to the 4/9 times C to the 9/10. Okay, so what I do know is that I do my parentheses first, and there is nothing further to simplify inside my parentheses, and now I'm just going to multiply. And the things that I can multiply together, well, I've got B's, those are like bases, and then I've got C's, those are like bases. So I have B 2/3 times B to the 4/9 times C to the 2/5 times C to the 9/10, like bases, adding my exponents. It's a fraction, but we can make it. So this becomes B to the 2/3 plus 4/9, and this one be times C to the 2/5 plus 9/10. In order to add fractions or subtract fractions, you have to have a common denominator. So when I rewrite these, this becomes B to the 6/9 plus 4/9 times C to the 4/10 plus 9/10, and that is going to equal then B to the 10/9 C to the 13/10, and that is my answer right there. Simplified. I showed you a lot of steps. It seemed to take a long time, but I was trying to show you all the math to where you understood what was going on. Continuing on with J here. Again, we can, there's some things that we can bring out of the equation to make it a little bit more simple for us. We do have 3 times 7 times 3 times 7, and then leaving behind some variables. And we have our J's, and we also have our M's. So our J's are going to be J 2/3 times J, the 1/6, times M to the 1/4 times M to the 3/2. Okay, and then I know doing some simplifying here, 21 times 21 I think is going to be 441 times, let's see here, J 2/3 plus 1/6 times M to the 1/4 plus 3/2. And I'm going to go ahead and, find my common denominators. I have 441 times, let's see here, J to the 4/6 plus 1/6 times M to the 1/4 plus 6/4, to simplify down to 441 J to the 5/6 M to the 7/4. And there you go. There's our simplified expression bringing all of our elements together. And that is simplifying, rational exponents, simplifying expression with that rational exponents without the need of a calculator. Okay, to sum up some of our exponent rules, we did cover the zeros, exponential form, and the negative exponents, but the product rule, remember, when you multiply the same base, you add the exponents and keep the base the same. So this is looking here when we have A to the B times A to the C, that is A, the same base, and then we add the exponents, B plus C. For example, when we have 3 squared times 3 to the 3rd, that is going to be 3 to the 5th, or 243. But if we have variables, of course, we would have x to the 3rd times x to the 4th, which is x to the 3 plus 4, or x to the 7th. So just remember, when multiplying like bases, we add the exponents.